That was a little bit kind of...
Everybody, that wasn't that.
Okay. Right. Let's have a look then. So we're having a look at this difference. So we've got 4 times 3, so it's 3, add another 3, add another 3, add another 3. That kind of makes sense. But what about the 3 times 3 times 3 times 3? What does that actually mean? Millie? So I have 3 in a group.
You add 3 of the 3.
Okay, so if I've got 3, then I multiply that by 3, so then I would have, so the next stage would be to have that, yeah?
Yeah.
So that is the 3 times 3. And then if I did 3 times 3, which is this, times 3 again, that would mean I would need 3 of this much. So I would then have to go 1, 2, 3, 1, 2, 3, 1, 2, 3, and then another 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay? So now I have, okay, if you think about it, I started with 3, and then I did 3 times 3. Then I've got 3 times 3 times 3. I've got 3 lots of that. 3 lots of 3 times 3. If I have to do it again, I do what? I have all of this times 3 again, which I'm not going to draw. So all of this that's already on the board, which is 3, sorry, 3, then it's times 3 to make 3, then it's times 3 again to make 3 of those. I would then have to times by 3 and end up with all of that again, there, and there again. So you can imagine there's 3 lots in each one, yeah? So that's 3 times 3 times 3. And then if I did it again, I'd have to think it's all of this times 3 again.
Oh my God.
So can you see how multiplying repeatedly gives you very different answers to adding just onto it, yeah? Yes, sir.
Oh, I was confused.
Yeah? Does that make sense? So that's why these two are very different. Which is why when we start looking at algebra and we have, if we have A plus A plus A plus A, pardon? Well, you just saw me right by mistake. Oh, right. Okay, so A plus A plus A plus A is 4A. Okay, and then A times A times A times A is A to the power of 4. So they're very different things. Okay. Right. I want to then look at, well, this whole collecting like terms, for instance. If I've got, this is the one thing I want to discuss with you. Let's say I've got f plus f plus f plus f cubed plus f cubed. Okay. Math.
You would simplify it would be 3f plus 2f cubed.
Yeah?
Yeah.
We all agree? Okay, now the reason is because f cubed is not the same as f. And I wanted to explain that today to maybe help people in the fact that let's substitute, okay, f for 2. So anywhere there's an f, we put a 2. And let's see what happens. So we now have 2 plus 2 plus 2 plus 2 cubed plus 2 cubed. Oh, sorry. You can see what's going to come. Alright? Now, it makes sense then. What's 2 cubed, by the way? Can you see that by doing the cubing, I now have 2 very different numbers? So how would I write this simpler, but without actually doing it, Laura?
6 plus 6.
Not do the 6 plus yet, not doing the answer, just
2 times 3.
can I do 3 times 2? Yeah.
Times 2 times 8.
Plus 2 times 8. Okay? If you wanted to simplify, that's what you guys would do, isn't it? If you were going to work that out, you would do, that's, in your head, you would do 6 plus 16, and then you would work it out, wouldn't you? Okay? Now you've got to do the same with algebra. So we've got 3 times 2 and plus 2 times 2 cubed. Now, would you be able to explain to me why it can't be, so why can't, I sound like the guy off Khan Academy, it always repeats, I don't know if you've watched it.
Yeah.
Why can't it be 5f power 4, for instance? Because that's what some of you would have written before. 5f. Well, first of all, could you explain why someone would write that? What's going on in their head? Serena?
Well, they see, using the F filter here, they see F, they see 5 Fs,
Yeah?
and they see, I don't know, wait, how do you get, I don't know how you go.
What would you write as another one then? So it can't be 5f
I would put cubed.
cubed. Okay.
So,
No,
That's-
there's no no.
I know
She's
it's
saying
not-
what she could have done. It's not right, but she's saying what she could have done.
so it's 5 Fs, and 2 of them are cubed.
Yeah, so that would be someone's mentality, wouldn't it? There are 5 Fs, 2 of them are cubed, so we have to put the cube somewhere. Christina, what?
I so the reason why I put 5 is like so because you've got the 3f and then 2f cubed.
Yeah.
Like they think, oh, I can't put that together, and then they have the 4 left, the times the power 4 because you have another f there.
Yeah.
So I think that adds to the power of 3.
Yeah. That's what I would say as well. Yeah. So.
Okay, and then things in quite a 4 when I was confused. When we go back to the f equals 2, they would put 5f6 power 6. I would put that.
Why would
Yes,
you put
like-
5f6?
And why?
No, but why would you do it if you were going to do it wrong? What would they be thinking?
There's 5 2s, and then there's
Well, there's no
Five.
2's because
Well,
we're
there's
dealing with
5
f's.
and then
So it's 5
you add
f's,
3.
and we've got 3 and 3.
You would add that.
Yeah, you add them
I think
together.
when we first started algebra, I would
You can also
Yeah?
do 5.
Yeah, I think you can see, can't you, how all of those are options. But what I would say to you is that you're only thinking like that if you just see f's and numbers, rather than thinking of what it actually means. So I think someone said to me when they did their quiz, oh, I just put some numbers in and thought what happened. Well, that's the whole point, isn't it, with algebra? The letters are supposed to represent numbers, so you can put the numbers in. So what you've got to think of is, if I said to you now, f is 2, alright, would any of these make sense?
So it'll be 5 times 2 is our 6. Oh gosh. So right now, if you put it in numbers, you choose the power.
I think from the letters.
Does that make sense to everyone now?
What kind of number?
If you chuck a number in, if you put one in, substitute it in and see what happens. I think all of you go, yeah, no, it doesn't make sense anymore, right? And you've got to think, so what I'm trying to get to is a little kind of mentality thing going. Algebra is working with numbers before you know what the numbers are. That's all it is, okay? So, for instance, let's have a look at one that Imogen asked, which would be, if I asked you to simplify 11y times 9z. Okay. What's the answer?
99 y.
99, my computer's frozen, y, z. Okay?
Why?
Yeah, go for it.
Because first you start off with the numbers, and then you times them together, and then you just add y and then.
See, that's a bit like, if you just say, oh, and then you just, if someone doesn't understand, they're like, what? I don't get it. Annabelle.
Get out the letters, and you just use the numbers. This is times 6 times 11 times 9. And then you put back in the letters, and it has to be in alphabetical order.
But again, you're saying, just put the letters back in. What does that?
Alphabetical order?
No.
Or that just which one comes first?
Yeah, it doesn't have to be in alphabetical order. Does it? I think I said it doesn't matter. It doesn't matter. Algebra, because the letters could stand for numbers. As soon as you change, alphabetical order is not a problem. Okay?
Maya just rang the bell in my head when she said my iMac. Did you get my email?
Yeah, I'll talk about it in a bit.
Did you give us one?
Well, on our little separate thingies on the whiteboard.
Yeah.
You say you want like this, and well, why is 99YZ? Because you could just take out the times sign because they're all getting multiplied together.
Yeah.
So, and then when my final answer first was, I had 9Q times 5P.
Yeah.
And what I put was 9. All I did was take out the times sign, but you said you didn't accept that as an answer. So what I did was just add those together.
Yeah. So what we've got to think, if it's 11 times something times something times something, or 11 times something times 9 times something. Again, what would you do if I said, well, Z was 3 and Y was 4? What would we do? We would make it 11 times 4 times 9 times 3. Okay? And what do you know about multiplication, Dana? Laura?
You can switch around the order.
Yeah, multiplication can be done in any order. And actually, for one like this, I would do, I'm going to do the 4 times the 3, because that's easy, and 11 times the 9. I would do, it's 99, 11 times, you can do it in any order you like, but I would do 11 times 9 is 99, and then we've got times 4 times 3 is times 12, and that's easy, because it's like doing 100 times 12 minus 12, isn't it? Yeah? But again, you can see how we did the 11 times 9, and then we did the times x times y, so, which we would then write without any multiplying. Why can't I leave it, though, as 11 times 9 times x times y? Sensation.
Because 11 and 9 looks like 119.
Exactly. So the rule is algebraic. It's like, we have to be able to differentiate between 11 and 9, so you just have to do it 11 times.
Mr. Fox, you're confusing all your viewers.
Sorry. Yeah, it should be a Z, shouldn't it?
Yeah.
I just swapped, confusing all my 3 viewers. So we have to do the 11 times the 9. Very rude. Okay, does that make sense? Now I'm going to, again, challenge you then to have a think about one of the harder ones, such as, let's do st plus s squared t minus 2st squared plus s cubed t squared plus st squared minus 2st. Okay, I would like you to simplify it. Now, if you can't, think what would happen if you put a number in for s and t. S and t, there's no 5s. No, it doesn't. My 5s look like that.
They're beautiful.
Mr.
Potts, can you scroll up for a second? For a second.
Right, what I would say is, if you're confused at all, what happens if you put numbers in? So, for instance, if I said S, well, pick easy ones, like S is 2 and T is 3.
Wait.
Careful with 1. Because 1 squared, 1 cubed, 1, it's all the same, isn't it?
Yeah, it's the easy thing.
Yes, but it doesn't help you. Because, for instance, ST then would be a
1,
2 times 3 makes 6, plus 2 squared times 3 makes 12, minus 2 times 2 times 3 squared, which is 4 times 9 is 36. Got to be careful with what I'm doing here, by the way. So what I'm actually going to do is I'm going to ask you at this point, there's something we need to rethink. We can't really do it in this way. I'll ask you whether you can figure out why. And then I'm going to do plus, it's 2 cubed times 3 squared, so that's 8 times 4 is 32, okay? Then it's plus 2 times 3 squared, which is 2 times 9 is 36, okay? No, sorry, it's not, is it? It's 18. Yeah?
3 cubed is not 4.
Where did you
Where have I got 3 cubes?
3, you said 2 cubed times 3 cubed.
No, I haven't.
3 squared. You said
Where's 3
squared
cubed?
is- No, 3 squared.
Yeah?
So 3 squared was 4. That's 9.
Oh, 8, yeah, sorry. 8 times 9, why don't I think that? 8 times 9 is
72.
Did you
72.
make
Minus, no, I didn't make a silly mistake. I made a mistake through not concentrating. It's not a silly mistake. And then I'm going to do minus 2 times 3, which is 12. Okay. Right. So there's a little problem with using these numbers to help me simplify by collecting like terms. Does anyone know? Because what I should end up with is all this, some same numbers, but I've done something wrong if I'm going to do that. Laura, what would you say?
Well, when it's numbers, you can't really differentiate the different terms, like whether
Right.
they're the same or not.
Well, I can, but I've done something I shouldn't have done if I want to. So, for instance, here's my problem. The terms are the letters, yeah? STs and things like that. Now, what I've done is I've got 2 lots of ST squared. Now, I need to leave the 2 lots of outside. And I'm going to write it's minus 2 lots of 18. And the same with this one. It's actually 2 lots of 6. Okay? Does that make sense?
I think I have these. Yeah, but
So what I've got now, you see, is I've got an S. Oh, I don't like the red.
Like that.
I've got an ST is a 6. Have I got any other 6s? Well, yes, I've got a 6, which is an ST.
Okay.
Okay, this is what I'm trying to get to. Then, for instance, I've got an S squared T. All right, is a what?
12.
A 12. Have I got any other 12s?
No.
Why does that make sense? Because I've got no other.
S squared. I mean, yeah, S
Yeah.
squared T.
I've got no other S squared T's. I've got 2 ST squareds. I've got 2 times 18. Have I got any other 18s?
Oh yeah, there's one there.
There's one here, look. And that's because I have another ST squared. Okay?
I thought like you could put together the 5 squared T and the 5 cubes because they're kind of like 6.
Well, you can see now that they're not. An S cubed T squared is a 72. Right? Okay, if you think you've got the answer, but let's follow this through. So what I want to show you is when you're collecting like terms, you've got to think of the number that it would end up being. So for instance, ST goes with any other STs. It doesn't go with an ST squared because I would end up with a different number. So basically my like terms are the ones that would also give me the same number at the end. So I've got an ST here and I've got subtract 2 STs. They go together because it's just STs. But what is 1 ST, put a 1, minus 2 ST? Fantasia?
Negative 1 ST?
So we've got minus an ST. You're okay if I don't put a 1, yeah?
Yeah, then take
Okay.
1.
Now that's done, because then it should make sense. 6 subtract 2 lots of 6 will end up as minus 6. So that's kind of sorted. So we're done with that one.
Wait, what? I did the ones that were the same.
Yeah.
My notes are so confusing.
Plus because ST squared.
Okay, I just want to carry on to get this finished. So ST squared is the only one that would be a 12.
Wait.
I've got the video, you can go back and do your notes afterwards, it's not a problem. I've got an ST squared, an S squared T. There are no other S squared T's, therefore I've still got to have an S squared T. Can't have any other. There is, however, minus ST squared plus an ST squared, which would be, no, because it's minus 2 ST squared, minus 2 lots of 18 plus an 18 would end up being minus an ST squared.
Wait, I thought so. And then that's what.
You're talking over each other.
But they can't plus.
Remember, the numbers are the coefficients. And then finally, the S cubed T squared, there is nothing that goes with it. Okay?
Yeah.
So, basically, no, I'm not finished. We're just doing it to get out of thinking. Okay? So, what you have to do, Ava, concentrate. You're away, you need to make sure you're doing this. Don't get hooked up with it's all S's and T's and therefore I can put them together. The reason why I tried to show you the numbers is to show you what would happen. The way you can't just put those numbers together, can you, and say, oh, it's, you know, again, it wouldn't make sense if you were to group it. So what would you go for if someone was going to make a big colossal mistake and collect everything together? What would you think they might do? So we could go with 1, 2, 3, 4, 5, 6, 7, 8, 9. So T to the power of 9. Okay, S 3, 4, 5, 6, 7, 8, 9. S to the power of 9. and then minus 2 is minus 4. Okay.
That looks gross. I don't know why.
Yeah, it really looks long-winded.
Now, can you see now? That makes no sense whatsoever. But that's what people try and do. Yeah.
Okay, well, I don't know, but I did it a completely different way. So, like how you kind of matched up two things.
Yeah.
I did that, but I matched up like different things.
But you can't
And I
match
don't
up
know.
different things.
But no, like they were like same.
Well, let's try one more.
I don't know.
Okay.
But can you like just look at it and tell me where I went off?
In a second, yeah, definitely. Let me write one for you. Another go.
No
Then.
idea.
So let's do 4w cubed y minus 2w squared y squared plus 3w cubed y minus w squared y plus 3wy squared plus 5.
They're like linked together.
Okay, now
So
what I would say is this. Another way to think of it, if you don't want to think of it as the numbers, what about this? Anything that's different, okay? So I'm going to take the term. What happened? Oh, it's got no. Right. I'm going to look at and separate the term from its coefficient. Okay? I'm going to do that.
Why?
yeah, that's what I've been doing, but
Okay.
blue noises.
Right, shush. I'm going to separate the term from its coefficient. Remember, the coefficient is how many you've got. And then I'm going to give a different, if you don't like colours or circles, what about giving it a different letter? So, for instance, I've got a w cubed, well, it's the first one, so I'm going to say, well, that's 4a. Okay? Minus 2 lots of, well, is that the same as that?
No.
No, so let's call it a b. Is that the same as either of those? Yes, so I'm going to go plus 3b. No, that's wrong, isn't it? 3a.
Because it's the same.
Where are these?
Is that the same as any of the others so far?
No.
No, so that's got to be a minus c. And then plus, is that the same as any of the others? No, so it must be a plus 3d. And then that's just a plus 5.
That's a good idea.
Okay, so this one is an A, and because that one and that one are the same, they have to both be A's. So I can collect those like terms, and it becomes 7, whatever A is. Okay?
That's good.
Now, we've got B, so I've got minus 2B plus 3, no, that's a D.
That's a D.
There's no other B, so minus 2B. Then I've got minus C plus 3D. Now, if we're going to do that, however, we've got to be careful. And then plus 5. We've got to be careful we put the right things back in place. So, what is it instead of an A? It would be a 7. Sorry, I'm not going to put 7w cubed y minus 2. So this was an A, this was a B, this was a C, this was another A.
That was the minus 2w. That was an A.
What's this
This
one?
was an A, and that one was a
That's an A, this one's a C, this one's a D, this one's a 5. Okay, so minus 2b would be w squared y squared, minus a C was the minus w squared y, plus 3y wy squared, sorry, and then plus 5. Okay, so there's actually not much simplifying to be happened. But can you see how you're looking at the term, and you're looking for it as its own little thing, its own letter, rather than looking at the W's and Y's as the same thing. Does that make sense?
Yeah. Can I do another one?
Okay, can I challenge you?
Yeah.
Yeah?
If you were to do, let's say, full W to times
Okay, timesing is different, isn't it?
That'd be like 12W.
So let's have a look.
In the power of 9,
What about if we do what Christina's talked about? Let's say we had 4W cubed y times 2W squared y squared. So something slightly different. What would you have here?
Well, you could multiply the 4 with 2 because you know.
Okay. So we basically have then 4 times 2 is that and that. Then you've got times w cubed times w squared. And then you've got times y and times y. So I've just rearranged it to put them together. So still collecting like terms.
But you can't.
So now we've got
you can do is
8. Now w cubed times w squared is different to adding, to timesing. So it becomes
W to the power of 5.
w to the power of 5. Because it's w times w times w times w times w. W to the power of 5.
And then y cubed.
And then just y cubed. So yeah, if it's all multiplying, it's different.
Wait. When we write answers, won't we get it wrong if it's not simplified?
If the question says simplify, yeah.
I understand that. So, because
Yeah?
so if you three, if you ever have like 2 powers, like if you always have say let's say a to the power of 6 times a to the power of 3, then you just add those powers together. And you, like,
Yeah, so if we've got a to the power of 6 times a to the power of 3, is that, how's that different to a to the power of 6 plus a to the power of 3?
Oh.
Yeah.
Okay, so with the to the power of, you know you're multiplying,
Yeah.
and so they're both multiplying that way, but in the other one you're multiplying and then you're adding and then
Yeah.
you're multiplying.
So if I gave you a number for a, you'd have to do that bit first, and then do that bit, and then add them together. So there's no doing it any simpler. But this one could be a to the power of 9, but this one can't be simplified, yeah? As is. Yeah, multiplying, but you can see how multiplying and adding are completely different. Right, I'm just going to give you another one, because we asked for it. What about, this is what we're going on to next, what about this?
Can we answer this in our book?
Yeah.
I love this.
Okay. Now, this is like beyond what we would have to do at the moment, but this does lead us into the next thing we're going to talk about, which is expanding brackets. But you don't need to at the moment. You don't need to expand brackets at the moment. But what we're going to do? Math investigation, huh?
I know that do this for
Ava?
Yeah, I have to do it. Wait, isn't it like because on the my math thing, it has like so with the bracket with the 2, you would turn it by x just 2x.
Okay. Just, I'm going to stop you at the moment. In a second, we're going to talk expanding brackets. Okay? But before we expand brackets, could we use the same collecting like terms that we've been doing?
Yeah.
Because, remember what I said, the number in front of the term is just how many of them you have. It's 2 lots of x plus 3. So, what are the terms? Well, I have an x plus 3.
You have another.
I have another x plus 3.
And would that be
And then I have
an x
minus 1.
and another x?
I'm sorry, that makes ugly.
So, if I collect like terms, I could have 2x plus 3 minus 1x plus 3 would make
1x plus 3.
Just 1x plus 3. I'm going to keep it in brackets at the moment. And then I've got plus 3x minus 1s plus another 4x minus 1s would be
7x minus 1. Oh. Me too.
same idea.
Okay.
Make sense?
And then the other one is 3x.
Okay. Now what we're going to do is we're going to go a little bit further and talk about expanding brackets. Now we've already talked about, well, we've got an x plus 3. We don't need brackets there, do we? Because there's an x, you add 3 to it, then you add 7 lots of x minus 1. Now what does 7 lots of x minus 1 look like? Laura?
X minus 1 plus x minus 1 plus x minus 1 plus x
7 times, yeah. Just in case you get lost track. Yeah, exactly. Does that make sense to everyone? So we've got x plus 3 there, but then we've got plus x minus 1 plus another x minus 1 plus another x minus 1 and so on. Now there must be a quicker way of doing it. So what we look at is if we were to put all this, line it all out, we could collect it all together. Now what we're going to do, this is what we call expanding brackets, and what we end up with will be, anyone know?
Wait, like, say how to get it?
If you like, yeah.
Okay, so first you start off with 7 brackets x minus 1.
So we're going back to we've still got 7 lots of x minus 1.
Now you do 7 times x.
Because we're going to end up with 1, 2, 3, 4, how many lots of x? 7 lots of x.
That's 7x.
So that will make the 7x.
Then do take away after 7x.
Well, that's because we would have how many lots of minus 1? 7 lots of minus 1.
Then you
So minus 7. So, and we've still got x plus 3 plus 7x minus 1.
7x minus 7.
Which would be, now collect like terms again, x plus 7x is 8x plus 3 minus 7 is minus 4.
But I got the rest of it. So is that even more simple? So wait, is
That is simplest.
simplest form of
Mr. Potts, is this part of expanding brackets?
Right, so what you've just done with
Where did the minus
that bit, that 7 times x minus 1 and doing this and ending up with the plus 7x minus 7, that's the expanding the brackets. Okay? So what I'll do is I'll give you a couple that is just expanding the brackets, just to do. So, for instance, let's do 2 lots of p plus 3. So let's pretend we've just got that. Go for it straight away. As soon as I've written, you can do it. Okay?
I need a new page.
Okay, so back in the room. Let's expand the brackets. No, you've had your time. Expand the first ones. What do we end up with? But if we were to write it all out, p plus 3, so it'd be like p plus 3 plus another p plus 3. So it would end up as 2 p's plus 6. B? Well, let's do it loud. We've got 2 minutes. Millie, what would you write if you were allowed to do it in your book?
We were not allowed to do it in the book.
You've run out of time. Chat too much.
I would do x plus 2.
Can we go straight to the quick way? So we're going to end up with 2's, and so we're going to end. How many x's are we going to end up with? So we're going to end up with 4 x's, and we're going to end up with 4 plus 2's, which would be plus 8. Okay? Who would like to do C? Yeah, write it down. Anna. Yeah. Easy as that, eh?
Oh, can I do
Go on then, Christina, be careful.
is it negative 2? 2? Yeah, no. Yeah.
Remember, we're going to have negative 2. It doesn't make an awful lot of sense. So we have negative 2 times 5 is...
You could take away...
What's negative 2 times 5?
Can I do this?
10.
Negative 10.
Negative.
And then we'd have...
Minus
And what's minus negative?
minus
What's a negative times a negative?
positive.
So we'd end up with plus
Oh, okay. So I
6.
I just put take away negative.